Okay. All right. Thanks everyone for being here. This really isn't a talk. This is much more of a session in which we're hoping to draw from the brainpower of everyone in this room to try and figure out how we should implement account abstraction in Filecoin. Some people in this room have been thinking about this for over a year now. I'm pretty sure Alex North opened the first discussion on this in June of last year, while others maybe are newer to the subject, but please don't let that hold you back from participating because we haven't figured it out yet. The people who've been thinking about it for a long while, so we really need fresh ideas, fresh thoughts, and creativity. And we're hoping by getting everyone here together, we'll be able to make some progress, break some ground, maybe come up with the perfect design that we all run with. So that's very much the purpose of this session. So it'll be fairly interactive. I wanted to quickly go through a definition of account abstraction and some challenges. We've already covered some of this. And then start off with a proposal. It's a proposal in quotes. It's very much just a starting point that we think we can build on. But if you see very obvious holes in it and need to tear it to shreds, please do so. If we think we can just mutate that in place, fill in the blanks, there are a lot of missing blanks, maybe that'll work. Yeah, we'll see where we get. Cool. So Scott already covered this, but I wanted to define account abstraction, and there's a few different definitions and a few features that get lumped into this term account abstraction. But I think in one plain speak sentence, account abstraction seeks to allow smart contracts to directly access the Filecoin network. And when I say directly access, I really mean trigger on-chain activity, which essentially means sending a message or a transaction. Today, the starting point for all on-chain interactions on the Filecoin network is a signed transaction sent by an EOA, an externally owned account. So someone owns a SecP key or a BLS key somewhere, signed some bytes, and sent that to the network. That is the only way on-chain activity can be triggered on Filecoin today. Account abstraction would that's not here. Account abstraction would expand this to also allow smart contracts to trigger on-chain activity, so send a transaction with some custom signature validation. There needs to be some validity enforced because you need to be able to say, yes, this contract wanted to send this, and it's not someone pretending to be that contract. So there's some custom validation necessary, but that can be a lot more than simply validating a signature. In particular, it can be stateful if necessary, so it can involve the state of the contract in some sense, which is not the case today with EOAs that sign transactions. Motivation, I started to put together a slide over here, and then remembered, number one, that Scott was already going to cover this. Also, the internet is full of motivations for account abstractions. So here are some screenshots of folks motivating account abstraction, and if you are interested, you can read EIPs, you can read FIP discussions, and there's some great blog posts as well. For now, for the rest of the session, we're going to take as axiomatic that this idea is already sufficiently well motivated based on what the internet has said and based on what Scott has said. So I'm skipping that entirely. Why is this difficult? Why have we in Filecoin and really the ecosystem more generally been struggling to design this and ship this? And these are in large part my opinions, but I think they hold true. I think the challenge is that when the idea of account abstraction pushes against some of the safeguards that we have in blockchain systems. In general, in almost all cases, when you're participating in a blockchain network, you don't care about performance of someone else's interaction, nor do you even care whether it succeeds or fails, because the system is designed to protect you against those things. You don't care if some contract, if you're a node operator that's validating the chain, you don't care if some contract somewhere has a method that's really inefficient, because the system requires that contract to pay gas for it, and so if it takes a long time, whoever's interacting with that contract is spending a lot of money. It's not your problem. Similarly, if you are a block producer, so storage providers in Filecoin, as they produce blocks, and you're packing transactions or messages, you don't care if one of those messages that you're packing is going to fail when it's executed. That is just completely irrelevant to you. All you care about is that it meets certain very basic criteria in terms of its gas properties that ensures that you'll still be rewarded for it. And if the message goes on to fail, this is completely irrelevant to you. The exception to this nice property that we almost always have is validation operations. So going back to the node operator, a node operator needs to be able to quickly tell whether or not a block is valid. If for some reason that can be arbitrarily slowed down, as you're syncing the network, you might be DOSed as people send you invalid blocks. Similarly, a block producer needs to be able to efficiently determine whether or not a message is valid, or they're not going to be able to know which messages they should be picking for inclusion in their block. If you're picking an unsuccessful message, that's fine, but you still have to pick a valid message. And so these operations need to be efficient. The good news is these operations are fairly efficient, waving my hands a little today. A block producer who's packing blocks today basically just has to validate some signatures. You need to validate, you've got some messages from the network, you validate the signatures, which is not the cheapest operation, but still fast enough to do. You know that the signature validity will never change. If a message is validly signed when you look at it today, if it's 3 days from now, it's still going to be validly signed. The other thing you have to do is quickly look up the sending actor state and confirm that the nonce matches, they have enough balance to cover the basic gas that they're advertising, and maybe a couple other things. But that's one read. You're looking up a state and saying, okay, you look fine, and now I've decided that this message is good for inclusion in my block. In particular, they do not have to run any custom logic. So the sender of the message or the recipient of the message does not matter in this case. It doesn't matter if you're a storage provider submitting a post, or if you're invoking some EVM contract method. As a block producer, I don't care. I'm looking at the sender state, and I'm looking at some gas fields, and I'm saying this is a valid message to include in my block. And all of this slightly goes out the window when we consider a world with account abstraction, depending on how we define it. Depending on the definition of account abstraction and the design that we go to, block producers would have to, or at least might have to, run the custom validation logic for the sending smart contract. This sounds more complicated than it is. Depending on how we design it, this would really just mean invoke or simulate some method on the FVM, on the Filecoin virtual machine. But that's still a lot more work than they do today. Further, this logic has to be run immediate at the time of message packing, at the time of block production, because it might not be the case that if the message looked valid yesterday, it's still valid today, unless we somehow enforce that, or if we somehow enforce the property that all of these validation methods have the property that if you're valid once, you'll be valid forever. But that opens up a question of how do you do that? And if that seems hard, then we say, okay, the block producers have to perform this validation at the time of block production, which is a critical time. That there's a 30-second window to produce a block in Filecoin, and you need to do a lot in those 30 seconds. So spinning up an FVM instance to validate these messages is difficult. This logic cannot take very long. No one's actually paid for this logic yet. If the message is in fact valid, then the message is going to eventually land on chain, and there will be gas fees that will be incurred and so on. But at the time of validation, you don't actually have any commitment that anyone wants to pay for this. And if the message winds up being invalid, if it takes you 5 seconds to validate a message and you decide the message is invalid, you've just wasted 5 seconds as a block producer. Next, you have to worry about whether the message's validity might be different during execution. So essentially, you need to be confident that whatever you're looking at, whatever's making you confident that the message is valid when you pack your block, that is still going to be the case when the message is actually executed on chain. If for some reason the validity changed there, then you have now packed an invalid message, and something bad is going to happen. You don't get your gas rewards. Maybe your block is rejected as invalid. Maybe you just get some minor penalty. Depending on the system, you get penalized in some way. And this gets worse in Filecoin because you also have to worry about tip sets. You don't know what the actual execution environment is going to be when the message is actually executed. There's going to be some number of blocks in a tip set. You don't know where in that range of blocks you are going to be. Good.
Yeah, quick question about transaction inclusion on Filecoin. Mm-hmm. Do we build blocks in our tip sets with reverted transactions?
With reverted transactions?
Yeah.
I don't know what a reverted transaction is.
So it's considered invalid?
No, yes, we include them. So like revert as like a transaction that reverts?
Yeah, so
yes.
like you run gas estimation, everything looks fine, and the state of the chain has changed in such a manner that your transaction reverts after being included.
Yeah, we include all the messages before we even run them. So the messages are included, we built this message to execute. Then in the next epoch, we actually execute those messages and just like put in a receipt on chain that says, and this transaction reverted.
Okay.
Yeah. This kind of goes back to when you're packing your block, you don't care what's going to happen to the message so long as it's valid. And so tip sets just tend to complicate things further. This is already a problem today, and there is some particular logic in clients of Filecoin to deal with that, but account abstraction complicates it further. Go ahead.
one thing I want to point out here, though, is the tricky part here is that, like, once we validated the message, we can charge the sender even if it reverts. If the validation fails, we can't charge the sender because we actually don't know if it was ever valid. That's the problem.
Oh, I see. Right.
Yeah, and like specifically if they charge for the validation process, not even for the message, just like the cost of validating it.
Yeah, I think maybe Scott meant to ask, does Filecoin include messages that are invalid in tipsets? And the answer is yes.
Well, and this is where things get tricky, right? So we don't include messages that are invalidly signed.
But that's not the full, that's not the whole validation. We already have the property, like it's already false that valid once, valid forever. There's no change here. It's already false because nonces change. So your validation depends on the prior state today.
Sure. Yeah.
And so tipsets can cause the prior state to change, and so a miner can include a message that is invalid, and they get dinged for it, and there's nothing they can do about it.
Ish. A miner cannot produce a block that has that includes a message with an invalid nonce today. Maybe this is getting a little too much into the details, but validation in Filecoin is split into syntactic and semantic validation, where syntactic validation is basically when you just looked at this block and its parent state, what did you know about it? And essentially, if we can say the miner knew that this was a bad message at the time of its inclusion, then that miner should never have included that block, and that's an invalid block. If, however, the reason for its invalidity is the tipset that the block wound up landing in, then yeah, things change. But you're right. These are all factors at play today that I think just get complicated were we to introduce account abstraction. In particular, because yeah, if we have more extensive operations, today saying an invalid message is basically painless because it's a quick signature validation, but that might change. Okay, any other, thank you for the discussion. At this stage, I wanted to jump into our proposal in quotes, but any other chatter before we jump into that, because this is very useful. Thoughts, questions, things that didn't seem quite right or don't necessarily have to be true?
I actually want to note, like, we are a bit inconsistent on when we ding the miner, when we don't ding the miner. So for example, like, if I send out two messages to the same nonce, and it gets included two different blocks in a tipset. If I recall correctly, basically the first one will get executed, and then the second copy won't get executed and won't get dinged.
Correct.
While if I send out, for example, a message that doesn't, where there's enough gas to cover that message, then the miner will get dinged. Correct. Which is a bit weird, because like here, we're dinging the miner specifically not for the cost of executing the message, but for the cost of literally validating and including it, like the cost of storage, the cost of like all of those costs. But we only ding the miner in one case, not the other, and it's a bit interesting. Yeah,
you're right. I think the rationale behind that was, again, if we know the miner should have known better, we'll ding them. But if the miner could not have known any better because they don't know what the other blocks in the tipset are, we don't. But even with this, we're not fully consistent. You're right. In particular, we don't bother checking balances. So a miner can absolutely include.
We do. We check balances.
Well, not at the validation stage. We'll check them and we will penalize the miner for it. But we could, if we wanted to take the other approach, we could just say this is wrong and not include this transaction.
But that would break the network. But yes.
Yeah. Cool. Yes.
Yeah. I think it's relevant to account abstraction. So I'm bringing up this example. If I have two transactions, one's included in one block, one's included in the following block. And in the first block, I drain my account, send it off to someone else. And in the second block, I have some amount of, I'm doing this work and I'm charging gas for it. Curious what like the network does with that case, because that feels a lot like the case of someone in the account abstraction world sends off a transaction and for whatever reason, there's no funds to pay the...
Yeah, you're totally right. And what the network does today is penalize the miner for it. So specifically, if there was a transaction in block A that, yes, spent all their money, and there was a transaction in block B that had the next nonce, they also need a transaction with the same nonce as A, but we'll put that aside, that requires some gas, the miner is unfortunately penalized in that case. This is true today. This is technically an attack on the network. It's just really hard to orchestrate. But yeah, in that case, unfortunately, the protocol looks at the miner, says this message, the sender cannot actually pay for just the cost of including this message, let alone executing it. So unfortunately, miner, you have to pay for that, and it's taken out from their gas rewards, from their block rewards. So yeah,
Okay, cool.
that case exists today for sure.
Thanks. I think that's helpful if we consider where you're taking us.
Yeah, totally. Cool. Anything else? All right, so now we get into the, oh, sorry, before I jump into this, I know that time is all over the place for various reasons. How much time do we have for this? 15 more minutes. Cool. Okay, so here's our concrete proposal, concrete-ish proposal that I want people to think about, tear apart, and maybe build on. This is we've talked about account abstraction and Filecoin in a few different directions. This is one that Steb and I talked about more recently, and the two of us, think it might be the most promising option, but that is in no means a strong vote of confidence. There are many different ways to do this, and we might well have to change directions. So this is very much intended more as a jumping off point than anything else. But our proposal is to have essentially a two-phase message execution process, where phase one validates messages without actually executing them, and we'll cover that in a bit more detail. And essentially, phase two executes them. So today in Filecoin, you pick the messages that you're going to be executing at a certain tip set by looking at the blocks in that tip set. They're all assumed valid because you've already valid signatures and nonces and so on, and then you just execute all of them in sequence. What we are proposing as a result of having account abstraction is that you pick all of those messages, validate them individually in sequence, doing one pass over all of them, then execute them all, doing a second pass, obviously only executing the validated messages, the validated messages, I should say. Any questions about that, Jennifer? Cool. Okay, so this is not especially novel or anything, but it does help with a lot of the problems. Around what happens if this step fails and so on go away. If you just say first we're going to validate everything before any other state changes have happened from executing messages, then we're going to execute everything. As we remember from the challenges section, a lot of the challenges around account abstraction were related to block production. So what does block production look like in this case? Well, block producers need to validate messages before including them in a block, as they do today. So they validate messages on the parent state of the block. They must follow the property that their message chains are fully valid. And what I mean by message chain is just multiple messages from the same sender. So if sender X has nonce 40, they can include 3 messages from sender X, provided it has nonces 40, 41, and 42. And 40 should look valid when validated on the parent state. 41 should look valid when 40 has been validated on the parent state, and 42 should look valid when 40 and 41 have both been dated. So if you're including M1 and M2 from the same sender, M1 must be valid on the parent state, M2 must be valid after the act of validating M1. And maybe goes without saying, but invalid messages are not included in a block. So block producers should not include a message they know is invalid. That would render their entire block invalid. Any questions about that?
When it comes to validation, you said that it needs to be quick. Is there like a gas limit that we're going to have on that?
This is one of our many open questions. That's TBD. Yes, we probably need some limit. We don't know what or how to enforce that yet.
Okay. 'Cause you might even have to check the balance of the target account before even doing the validation. Because you might just be like, oh, you don't even have the gas to pay for the validation.
We already do that today. So like making sure the sender has some money is a step we already, or has enough money for the funds is something we already do. But yes, you're right.
And will there be any constraints on the validation? Like during the validation, you cannot touch this like state or something like that?
Also open question. This is stuff that we'd like to talk about. Cool. As for block validation, it's kind of the mirror image of that. When a node operator receives a block, the first thing they do is validate all of the messages in the block. If any of the messages in the block fail validation at that stage, you can just throw out the block is invalid. So the block is rejected as invalid. And now when it comes to actually state computation, this is where the two-phase stage happens. So messages are revalidated at this stage and then executed. So first you select the messages for execution. So you've got 5 blocks in this tip set. Select which messages will actually get executed based on nonces. This is exactly what we do today. And it is mostly about resolving cases where a sender has multiple messages with the same nonce but in different blocks in the tip set. So there's 2 different messages with nonce 40 from sender X in block 1 and block 2. And then you just skip the message in block 2. Then validate all of the messages in order on the parent state S, charging gas for validation as we go. Charging gas for validation is a little hand-wavy. We need to specify exactly what that means. Do we just deduct funds? Do we also reserve funds for the message execution? We probably need to do the latter, but that's unspecified for now. In the unlikely but possible event of an invalid message at this stage, the block producer pays a penalty. If a message was invalid, kind of when you evaluated the block by itself, you just throw out the block entirely. If a message is invalid when you're actually executing state, then the miner pays a penalty. And again, this is analogous to what we do today. And this gives us a new state route now that all of the validation has been done. Gas has been charged, funds have been reserved perhaps, and then you just execute all your messages. This, I think, resolves a lot of the complexity that, so the obvious drawback of this is you're kind of doing things twice, but I think it resolves a lot of the complexity that we've been running into with discussions. It feels like the most feasible option, but that certainly may not be the case. And we have a bunch of open questions to discuss, but go ahead, Scott.
Yeah, and you know I have one. So that makes sense and is simple. There are some edge cases, right? Like the semantics of it matter because if you, let's say you validate all the messages and you deduct the gas, maybe depending on the transaction ordering of how they're executed, the assumption of, oh, well, my execution happens after this, or this other transaction removes some balance from an account such that it no longer has it. Like, how that will play out determines if transactions are validated and executed in sequence or all validated and then all executed later. Does that make sense? Like,
yes, that totally makes sense. And a big part of the challenge is if you're validating and executing, if you're validating, executing, then future validations become a lot less predictable. That's basically the motivation for the just validate them all and then execute them all. It is still totally the case that some messages' validity may change as a result of the tip set shape, but most of those cases we're hoping will be removed by validating everyone in order, then executing everyone.
but when I submit a transaction, I'm not, like, I consider my transaction an atomic thing. That's why it's called a transaction. But what you're really doing is you're breaking it down into 2 state transitions. And so, like, the non-determinism of the sequencing of the rest of the transactions in that block could impact my execution on the tip set in an undefined way that seemed like it was fine when I submitted it.
So I think one way of thinking about this is it is 2 operations, but effectively the first operation is paying for the message, and the second operation is actually running the message. So the idea here is you basically, in the validation stage, it's why when you validate the message, you basically reserve then all the funds you might need to actually execute the message. So that's like your first operation. Then you go and you execute the message, and then you refund.
No, I understand. Listen, let me give you an example. There's 2 transactions in a block, and I go through and I validate each of those, and they each pay their gas. Then the second, that first transaction actually executes.
Yep.
And what that does is drains the account on that second transaction. Now the execution fails, even though it wouldn't have if, like, that wouldn't have even been considered a valid transaction if you had done it the other way.
Yes.
But that's why we reserve the funds. So literally, like during the validation stage, you reserve all the funds you need to execute. So you reserve the gas fees up front. So the first transaction there cannot drain those funds from the other account. So the other account will run.
But I guess I'm saying is, like, as a user, it's very difficult to predict that behavior. And, like, as a user, I am submitting a single transaction, but what's happening is you're breaking it up, absconding with pieces of gas from each of those, and then interleaving them to the rest of the block that I have no visibility into.
Is the problem that like even if you execute locally to get a rough estimate of how much gas there is, by the time it actually gets executed, the number might be different, and so you have to put a bunch of extra cash aside. Like, is that the concern, or?
If you just look at the word transaction,
Yeah.
it is a fully synchronous thing that in this scheme, you are breaking it up into two discrete executions, which is validation and execution, and then interleaving other activity in between what I would consider, a fully synchronous
So
execution.
with you can have concurrent transactions, right? Like as long as you don't end up, as long as the critical region doesn't get written into at the same time, right? You should be able to, and if it does, you can detect that, roll back and retry, right?
But I don't know if that's your, like, I don't know if you're even talking about concurrent execution necessarily so much as, like, you're right, for what's right. I think you, like, yes, this kind of like one-step thing called the transaction is now being broken into two phases. I don't think I necessarily see a problem with that, but there might be.
I actually want to say I think it's already happening. Like we already do that implicitly, where the signature validation happens first as the validation step. It's just that's not currently used programmable, and then the second step is you actually run the message.
But you don't, right now, you don't charge users gas
We do.
for validating
Well,
the
you do.
We do.
transactions.
We just charge them later, but we still charge them gas.
But that is a real difference, though, I think, right? Where today we look at it, we say if it's invalid, you just throw it out and never look at it again. And if it's valid,
right.
you say, I know that like 5 minutes from now you'll be charged when we're actually executing this message. Whereas to Scott's point, that's no longer the case. Where now there is a possibility. Now you are going to be charging gas when you look at it.
Yes, although like the way we validate messages, we ensure that you could not have possibly spent that money. Here, we're just ensuring it in a different way by reserving it. So like when we validate your sequence of messages, like there is no way to force an account to send funds without sending a message from that account.
Let me think about it from like a smart contract developer's perspective. If I'm building an on-chain smart account or like a smart wallet, and I have like a verify signature like entry point, and then the rest, you have the execute method or whatever with the call data. I have to consider the possibility, and I'm going to use this phrase bluntly, and it's not exactly one-to-one, so try not to get lost, but like you're essentially sandwich attacking my own transaction by putting other execution in between when I validate and when I execute. So I have to consider and potentially revalidate other state before I execute.
Yes, that is a good point, and that's so like there are a couple of things to help us here. One, during the validation stage, the entire system is immutable, so you can't change anything based on that. The other thing that does matter is, well, okay, one thing we can do
It's
here.
mutable because you're eating gas.
You are eating gas, yes, but that gas is already reserved. So like the idea is you like at the very, very beginning, you've reserved all of the gas for all of the messages. That's the idea here. Then like you run the validation step, but you're not like, you can't update your state. The other thing we can't do here is we can't just run validation twice. It's more expensive, but we could literally say validate once and then validate again when you actually run the transaction. We're not proposing that currently because that is more expensive. The only reason to validate once up front is it means you can figure out who to blame. So the problem is if we don't validate gas, or we don't validate the message up front, then we don't know if the miner included an invalid message, or if the user, or sorry, if the state changed that made the message
What's
invalid.
the implicit security assumption of that, right? Like, who to blame? Like,
Who to charge for?
ignorantly, I'm going to say, why does that matter?
For the problem is the validation has a cost, and the storage of the message has a cost. So we need to charge someone for the fact that the message was included on chain, and that all clients will now, or all validators will have to validate this message and run a little bit of code to determine that yes, this message is invalid. That's why
I
we
could
want
spam the network, and at a minimum, you're going to have to make sure that I have enough gas to do the validation. So you're still doing work for every time. I could just sit here and just spam nonce. I could just spam the mempool.
But the difference is that's spamming the mempool. It's not spamming the blockchain. So like that's something you can do, but that's something that can be more easily rate limited. Where a miner can basically they can say, okay, I'm only going to dedicate this much to validating these message types. Maybe I have like a whitelist of ones that I trust. So like if I'm overloaded, I'm only going to work on those. You can that you can deal with. It's hard, but you can still deal with it.
There's
Once
also,
it's on
there's
chain,
also
you
a lot
have
of,
to deal with it.
Yeah, there's also a lot of that's already true today. I think with these points, for instance, that's true today. You could spam messages today. If they're invalid, then they'll get thrown out and people will eventually stop listening to you because you're giving them bad messages. And if they're valid, then you're paying for something, assuming they land on chain. So yes, account abstraction kind of worsens all of this because some of these steps get more expensive, but a lot of this is the case today, I think.
I also want to, there was a third option we actually considered, which was time travel.
Yeah.
So another way of doing this is literally... Time travel? Yes, time travel.
I want to hear this.
You literally, like, you validate, execute, validate, execute, validate, execute until you find an invalid message. Then you say, okay, who to blame? You go back to the beginning of, basically, you roll back the state to the beginning of the block. You don't have to roll back, you just basically construct a new FVM at the beginning of the block, and you rerun validation. And then, based on the result of that, you either blame the user or you blame the block producer.
I like this personally. The problem with that, I think, is chains, where if you have 3 messages in the same block from the same sender, and the third message is what looked invalid, now you don't want to roll, if you're trying to figure out who to blame, you don't want to roll back to the start, to the block's parent state. You want to roll back to the block state after the second message was validated, right?
Actually, no, in my opinion, you'd roll back to the very beginning, because again, like, you're looking at, like, what should the have, or what should the, oh, I see.
Just blame the miner every time. It's just so much simpler, right?
So that's what we currently do, but the problem is then you can attack the miner, and the miners have no reason to include these messages. Because the problem there is, like, if you always blame the miner, then users will start submitting messages, or might start submitting messages that are, like, they look valid and suddenly become invalid, and now, like, no sane miner is going to take this risk and include these abstract messages, because then they're going to have to constantly be paying for the
Indeed,
cost.
I think one of the big goals of this design is to figure out as many cases where we don't have to blame the miner and can instead say, blame someone else or handle it elsewhere, because otherwise it's more attackable. So.
Now, how much of this is because of tip sets, and how much of this is just general account abstraction? And the reason I ask that is, like, we should go visit the 5 or 6 benched EIPs and understand why each of those either got deprioritized for other things, like 4844, which makes sense, or died on the vine because of X, Y, or Z reasons. Like, if it's tip set related, okay, we got to go do it. But like 3074, like, is it just lower on the priority list, or there's some fatal flaw in how they're doing the security of validation that makes that an issue?
A lot of, like, the core reason is tip set related, because you just don't know what's going to be in a block. So, like, we could do the whole, like, okay, you have some third party that bundles up the messages and submits that. But the problem is if I have, well, okay, fine. I take it back. Even with tip sets, I can have that approach where, like, I can have a relay, and that relay can basically take a bunch of messages, bundle them up, and send them on chain. That can happen. The problem is then we have this problem that you mentioned in Ethereum, where you have to specify, here's my relay, and you can only use that relay service. And that was that was what we were trying to avoid. We wanted to be able to say, look, you just publish your message to the network and it gets included and you're done. And anyone can include it, and there's no, like, you don't have to, like, point at someone. So, like, yes, the simple solution here is you have a contract on chain that says, like, it basically locks up some funds or something for some relay, and then you use that relay, and then that relay is always the party you use. They're the only one that can include your message, and then none of these problems happen. Because basically now that relay is taking on the risk, but they also have all the control. The thing here is we're trying to avoid that.
Yeah.
So,
Okay.
yeah.
So you were trying to get. Do you want to get?
Just going back to time travel for a second. Just pretty meta.
Going back to time travel.
So just also want to say I like the time travel version as well. We're thinking a lot about similar, like, obviously the details are very different, but we're thinking a lot about, like, who to blame and similar things in IPVM, and that's where we've also landed. If the concern is, if you have to jump to the very beginning and re-execute the whole thing, is that an attack vector because you're doing all this extra work, or something like, is it, like, I mean, I doubt that'll actually be the case, right? Like, realistically, it's probably fine, at least as a first step, because you can always change this behavior later, and you can probably just step back, like, literally unroll, try this one, and because this is, from the point of view of the external world, Filecoin is, or the FVM execution at least, is totally pure, right? And deterministic. So you should be able to run that last step. Last step was okay, cool, let's go up another one and try from here to here, right? And, like, as long as you keep the inputs and the outputs, you should be okay, right?
It's really hard because like when we don't serialize between messages, we actually keep a bunch of state cached because otherwise it becomes really, really expensive. The other problem is we can't really time travel. So like we can go back in time in the block, but we're still going forward in time in terms of gas. And we need to be able to like charge accurately for that gas cost, which means like any time travel solution, what it really involves is basically like going back, then charging someone for the cost of going back in time and starting over at the beginning, which means losing the cache and all this kind of stuff, which basically means that like this extra validation step, if we had to actually do that, would cost a fair amount, and we then have to either charge the miner or charge the user that extra budget of gas, which means we have to like pre-reserve that budget of gas at the very beginning. So regardless of what we do here, we'd have to like make sure that the user has enough gas to cover both validation and some kind of blame operation if it gets to that.
Why not bake that into the gas, like everybody's gas model? Instead of saying, well, we're going to charge you for the extra execution, just increase everything by 1%. And now, no?
It can just be like, well, there are two problems with that. One, that still becomes an attack vector because now basically you're shuffling costs to other people who are not taking it. Like basically you're shuffling costs from someone who's like doing something they shouldn't be doing to other people who are doing what they're supposed to be doing. And second of all, like the costs here are actually probably non-trivial. Where like doing the validation is probably reasonably inexpensive, but we also have some parts of our gas model where we literally assume amortization over the course of the block. By time traveling, you're basically having a single message block, which is significantly more expensive.
Here's a question I have for you guys. And like it's difficult to speculate on say like how Ethereum does it because they haven't. And 4337 is an abomination in my book. But ZK Sync has an active mainnet with native account abstraction in it. And they have like an iAccount interface. Their create and their create2 opcodes are implemented a little bit differently under the hood. And they have either figured out how it at least works for their version of the EVM, the ZK EVM, or they have made trade-offs that they're comfortable with. And while I can't say integrating with their account abstraction was very fun, since they broke a lot of stuff, what I will say is that they think they've done it. And so it might be worth understanding their validation and transaction inclusion scheme. My guess is you'll see some of the trade-offs they'll make, and you'll at least have a couple additional data points of like, okay, someone else thought about this and made this choice, which is informative. And you'll also see maybe what they solved or didn't solve because they don't have tip sets. So it's worth considering ZK Sync.
Yeah, totally. I've personally not looked at them. Does anyone in this room have familiarity with them that can speak to it?
I mean, I've tried to build abstract accounts on ZK Sync to a degree. We can talk about it, but like you guys are going to want to dig in the layer below the EVM to see how that works.
Sorry, I wanted to quickly go back to one thing that you said, Stabak. So in lieu of time travel, taking the double validation approach, that's actually what I propose here, as I was thinking about this a bit more after we talked, of essentially messaging, essentially checking stuff at the, when the block comes in stage and when you actually execute the block stage. So essentially you're doing it twice. This, I want to argue, is maybe fine, because block validation is, I'm hoping there's enough dead time, basically, so that we can perform that first phase of validation when we're just kind of like waiting for stuff to come in. So essentially when you've just computed the previous parent state, and at that point you can just validate the messages too. And then, and it's only, so at that stage, just reject the block entirely, is my proposal. And then obviously if at the state computation stage something has changed, because it's always possible something to change, at that point you blame the miner. If we think that's, all of these details are open to change, but I think that might just be fine.
Actually, we can also do them in parallel, I think. So there may be a world where we could basically run validation, because we're validating both cases, but one case is effectively the blame side, and one case is like the actual execution side.
Yeah. We
might be able to like basically reserve all, like say, effectively 3 stages, or like one stage up top where we reserve all of the funds that we need. One parallel stage where we call validate on the beginning of the tip set, effectively.
Sure.
Sorry, on the beginning of the at the beginning of the tip set, and the other parallel track where we actually validate, execute. This might be an option.
I don't think I fully understand.
Well, so, but my point is if, how to put this, there's no harm in, so like, what we could do is say, if you validate the message once up front, then we won't, oh, let me think. Oh, I guess no. So the problem there is if the message validated, okay, so the problem is if the message validated in the in the normal executions, like we have validate, execute, validate, execute, validate, execute. There might be a weird case where like the message validates during that and then doesn't validate during the, like in the first stage.
That is possible.
That's really weird.
Yeah.
But like you honestly don't care about that. Like if that happens, okay, fine. What you care about is the other case where it validates and then doesn't validate.
Yes.
But that's fine here, where you just do validate, execute, validate, execute, validate, execute. Oh, this one doesn't validate. And then you would just say, okay, skip the execution, continue on. Let the other thread do validate, 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 validate at the very top of the block.
Sure.
And then again, if you do this in parallel, like basically at the very end, you wait on both of these processes to finish, and then you use the pure validate stage to basically determine like effectively who to blame.
Any penalty.
Yeah. So like it's like the go back and blame version, except because we're doing this in parallel, we don't have to charge anything else for that. So it just required 2 threads. But also, for example, like this only has to happen when you are like maybe this doesn't happen maybe this doesn't have to happen all the time. So like if you're validating a block, you have to do this. But for like if you're doing state execute, like state compute on a block, maybe you can skip this in certain cases where like you're just rerunning the computation, you just skip the whole validation thing because you don't actually care about that.
Yeah, because I think you're right.
Maybe. Like, suppose we don't encode gas outputs in the block itself, which might make this a bit trickier, but there might be ways of like massaging our APIs that you don't always have to rerun that. On the other hand, the cost of it, again, like running a separate side thread that basically spends very little time just like quickly running through these things is not super expensive.
I agree.
The biggest problem is that like it might take up some of our bandwidth with Badger, so we'll have to be very careful there to make sure, because like right now we kind of assume that you have effectively 1 thread accessing Badger at a time. This will have 2 threads accessing Badger at the same time.
Yeah.
But yeah.
Yeah. Okay. I would like to. There are other open questions here. Sorry. Quick time check. Are we good to keep talking, or should we?
No, in 15 minutes there's a group photo, so if we want to get any lunch, we need to take that in the just 15 minutes.
Yeah. Sounds good. For version 2, I would really like to talk about how we can extend this to allow for paymasters or gas sponsorship and so on, because I know that that's something that comes up a lot in terms of desired use cases. But we'll take that in phase 2. Sorry, Micros, I know you had a point a while ago. Would you like to jump in?
Thanks. I think the biggest part of this that makes it seem like it can work without a conflict and make sense is the initial upfront gas reservation. And I think there's just some nuance there that took me a second to think through. And it's sort of like there's a minimum amount that you need to pay to make the transaction even happen.
Yeah.
And then from there, maybe the first opcode causes you to run out of gas or something. Because there was some back and forth about reserving the funds. How is there enough funds? How do you know? Blah, blah. But I think that like minimum, and I'm thinking of like how New York City cabs work, which is the second you walk in them, it's $5, and then it's 20 seconds a mile or 30 seconds a minute or whatever. And I think that seems really like seamless and appropriate here, where that makes sense, where someone initiates an account abstraction transaction, and all the miner maybe needs to do is just see, do those funds flag back to an account that has those funds, just to make the thing happen, not necessarily to make it succeed, but just to make it get to the table. And I'm just chewing through that, and not necessarily seeing any quite conflicts, or it seems okay, it seems interesting.
Cool, sounds good. Lots more to talk through. In the interest of lunch, maybe we'll wrap up here. Thank you very much for the discussion, and we'll definitely need a second phase of this. it'll be a lot of iterating before we actually get to a concrete design here, I think.